Welcome all once again to John Academy. Today we're going to finish the last set of exercises of the Algebra 2 Regents 2026 January exam. And these ones are going to be the ones related to functions. So let's jump into that. So the first exercise we have today is this one, number 4. We are asked which of the graphs represents this function, no? So first thing we have to do, as we are given some points, we are going to do the logarithm of base 1/2 of 1/2, no? And this should be equal to 0 for the first two. So let's do this on the calculator, no? Let's enter this, which is pretty simple, no? And we can see we are getting 1 instead of 0. So we can already discard the first or these two options basically, no? And now let's do the same with the logarithm in base 1/2 of 1. And that one should be equal to 0. We can check it now here. And yeah, it's equal to 0. Therefore, it has to be either 2 or 4. And how can we decide which one is the correct one? We can take another value. So we see, for example, for x equal to 5, no, somewhere here, yeah, we're gonna check either if it's above or below the x-axis, no, either if we get a positive or a negative value. So let's do logarithm in base 1/2 of 5, and that on the calculator we see we get around minus 2.32. So that means it's negative. So it's gonna be the second option here. Let's jump into number 5 here. No, we have a sinusoidal function, we see, because it's repeating itself. And yeah, all of the options are cosines, no? Yeah, ht is the height of water. What is the equation basically, no, of this graph? So what can we see? First of all, here it goes from 3.4 up to 0.4, no? So the difference is 3.4 minus 0.4 is gonna be 3. Therefore, the amplitude is gonna be half of that, no? Amplitude is gonna be 1.5. Why is that? Because the cosinus goes from +1 to -1, no? So we are already between the second and the fourth option. And then what else can we check? We have to see the period, no? We could check. So what we can see, well, another option will be taking one of the values, no? But yeah, what we can see is it goes from 6 to 18, no? So that there it makes a whole period, no? It starts repeating itself once again. So this here is gonna be 2 pi, a whole period usually. But we have either pi over 6, no? If it was the cosinus of t, the period is 2 pi, no? But we have either pi over 6 or pi divided by 12. So it's gonna end up being the fourth option here, this one, because it divides 18, yeah, we have 18 minus 6 equals 12. Yeah, and then, oh, sorry, it's gonna be the second option because we are gonna enter there, no? And then times pi divided by 6, the 12, you end up getting 2 pi. So it's gonna be this one, second option. Now we can jump into number 7. Here we are given sine of 2 pi thirds is equivalent to, well, here we have to remember there is a property, the sine of theta, any angle theta, is equal to the cosine of pi half minus theta. So if our theta in this case is 2 pi thirds, and then we have pi half minus 2 pi thirds, we have to do this operation here, no? We write everything into 6, no? So it's gonna be 3 pi over 6 minus 4 pi over 6, no? Also, yeah, so we subtract both and we end up getting pi minus pi over 6. And then we know the cosine of x always equals the cosine of minus x. Therefore, it's gonna be this option, the second one, the cosine of pi over 6. Let's go into number 13, which graph represents a function that has a remainder of 0 when divided by x minus 4. So if this happens, the remainder of 0 when divided by that means that f of 4 equals 0. No, it has a root at x equal to 0, or x equal to 4, sorry. Therefore, we look into the different options, no? Here is not a root, here is not a root either, no? Here is not a root either, it's just the first one that has a root there at x equal to 4. Therefore, it's going to be the first option. Let's jump into number 15 now. Which function could represent the sketch below? No, a, b, c, d are all greater than 0. So we have three different roots, no? So what happens? Here, that means we have a factor of the kind x minus d. This here is going to be a factor as x plus a, no? And the one here is going to be a factor of the kind of x, well, yeah, the x is going to be multiplied by c, no? So it's going to be cx plus b. And now by looking into the different options, no? The only one that has all those three is going to be the first one, no? Here has x plus a, cx plus b, and x minus d. It's always x minus the root, that's why. So it ended up being the first option. Let's check now number 20. We are given that the directrix of a parabola is y equal to 7, no? So y equal to 7 is here. Then the focus is 6 units above, no? So we have a parabola, it could be of this kind, no? And then the focus is around here, no? And this is 6 units above, no? And what we know always is that the vertex of the parabola, we could do it some other color, let's say orange, this has to be halfway between the directrix and the focus. Therefore, this is 3 above and 3 below here, no? So 3 above y equal to 7, the y has to be equal to 10. Therefore, it's the third option, no? Or at least it has to be 3 away. It could be also below, but none of them have a y equal to 4, no? Which will be 3 below. So the only option is number 3 there. Let's check now number 20. This is the tangent of an angle, no? So let's do a small sketch here to have a better intuition of what's going on. So we do this small set of axes, no, here, and they tell us the tangent of this angle. We can do something like this. Is in quadrant 2, therefore this one, no, here. And what do we know? The tangent is always opposite over adjacent, no? And the opposite in a second quadrant is positive and the adjacent is negative, no? Because it's going to the left. Therefore, if it's minus 1/6, the tangent of the angle is going to be opposite over adjacent, and it's going to be probably, no, yeah, the only option for that is going to be a square root of 6 divided by minus 1. And now we could calculate the hypotenuse, no? The hypotenuse using Pythagoras is going to be, we can write here hypotenuse is a square root of the sum of the squares, no? So square root of 6 x squared plus minus 1 squared. And then what are we getting here? This is going to be a square root of, this is going to be 6 plus 1, therefore it's going to be a square root of 7. So this is a square root of 7, and now we need to do, they are asking the cosine, no? The cosine, we remember now by SOHCAHTOA, the cosine of this angle should be adjacent over hypotenuse. And we know both of them, therefore it's going to be minus 1 divided by a square root of 7. And that's going to be exactly the fourth option. So we went for that one. Now for number 28, they are asking us to graph this function. So let's jump into the calculator, no? They are asking us to graph that and also state the question of the asymptote. So let's jump into that. So here we enter the function we want to graph, and now we go into graph here and we see how it looks like. Now we can also click into trace, no, to see some of the key points here, and also get a table of values. No, we could get this table of values. So let's take a screenshot here and graph it over the exam. So once here back in the exam, no, at x equal to 0 we have -1. Then we have for 1 is 0, another point there. At 2 is equal to 2. What else do we have? At 3 is equal to 6, no? So it's gonna be looking at 3 is 6, therefore is here. Then we have also, well, we saw it's looking like this on also, no, on the left. So it's gonna be looking somewhat like this, no? We could be taking more points even. Yeah, it's more or less like that. But the key part is also the asymptote. The asymptote is horizontal, as we saw here, and it's gonna be at y equal to 2. So we can draw that way, no? More or less the asymptote. So we have to answer here also y equal to -2, sorry, yeah, -2. Let's go with number 35, lastly. State the maximum value of dt. The maximum value of this function, because of being sinusoidal and periodic, is going to be when the cosinus is equal, cosinus of that equals 1. The largest value it can take, the cosinus. Therefore, dt is going to be 6,800 times 1 plus 6,400, and that's gonna be 13,200, no? That's the maximum. The period of dt, for doing the period we have to do 2 pi divided by the number we have here in front of the t, no? So in our case is 4 pi thirds. And if we do this on the calculator, no, 2 pi divided by all of that is gonna be 4 pi divided by 3. So we are getting 3 over 2, no? Which is equal to 1.5. That's our period. Very good. And lastly, determine the average rate of change between these 2 points, no? So we are going to do the second one, d2, the value of the y there, minus d 3 over 4 divided by 2 minus 3/4, no? And now we have to substitute the value 2 in the function. So let's do that on the calculator. 6,800 times cosinus of 4 thirds pi times 2 plus 6,400. So that's when t equals to 2. We have to do that in radians. Yeah, that's gonna be 3,000 here. We have to set up the calculator in radians, no, for this exercise. Minus, here is gonna be the same but for 3/4, no? So let's do it once again. So it's 6,800 times cosinus of 4 thirds pi times 3/4 plus 6,400, no? This is gonna be minus 400. We have to enter both minuses, no? And then below is just this, no? So we enter all of that. And let's write everything in the calculator all together. Above we have 3,400, no? And below is gonna be 2 minus 0.75. And that ended up being 2,720, no? That's the average rate of change between those two values, no? So this has been all of the exam now for the Regents 2026 Algebra 2, and we will continue doing other exams, no, for this year. We see us then, and I hope you learn how to do these exercises.